Okay, what's up, everybody? All right, what's up, everybody? Today we're going to be talking about the integumentary system. It's pretty much we're going to be discussing its anatomy and its physiology. So let's begin. So let's take this away. Integumentary system. So what it is, our integumentary system is pretty much our skin. All right, that's the skin is the layer that covers up our whole body. It's called the integument. That's the scientific name for it. It is also considered the largest organ in our whole body, which makes sense, right? You have this whole layer covering your whole body, right? Covering your skull, your chest, your abdominal cavity, your thoracic, your lower cavity, and all of that. So that's why it's called the largest organ because it's also a functional unit. It does work for us, right? Which we will discuss in the next later slides. It's composed of two layers. I would say two main layers, but it's really we kind of consider them three. So you have the epidermis right here, which is this top portion, and then you have this matrix layer over here, which is actually composed of areolar connective tissue and reticular connective tissue, but this is called the dermis. And then the third layer is actually called the hypodermis. Okay, the hypodermis or the sebaceous layer or the sebaceous layer. Now, not a lot goes on in the pretty much the fat layer, except that we do have some glands called helicrine glands that secrete sebaceous fluid, which we will discuss later in the slides. But yeah, that's pretty much it for this slide, for that part at least. And then we have our accessory organs. So our accessory organs are pretty much just those accessory types of tissue are that help aid our system, our skin system, our integumentary system. Okay, so our hair cells, we have our hairs, uh, our nails, and our cutaneous glands. So our cutaneous glands are these little glands right here that secrete sweat, or it could be if it's fat, if it's helicrine glands or sebaceous gland, they'll secrete something called sebum, which is an oily substance. And pretty much that oily substance help wash away any microbes or anything that might be on your skin. Okay, so next slide. So now we're going to be talking about the functions of the skin. There's a quite bit of functions. So the obvious function is protection, right? So it protects you like from getting any cuts or bruises from, well, I want to say bruises. I would just say any cuts or any sort of damage, external damage that you might inflict on yourself, right? Infection. It protects you from infection by pretty much kind of following that same principle of protecting you from cuts and stuff. It just forms this barrier, disabling microbes, any potential pathogenic microbes living on your skin or attaching to your body from entering your body. Okay, that's why potentially forming cuts, getting cuts can be extremely dangerous because you by getting cut, you create an opening or an access point for these potential pathogenic microbes to be able to enter and to invade uh, your body, right? And you definitely do not want that. And then third thing is you have UV radiation. UV radiation, UV stands for ultraviolet. Ultraviolet is just this form of high light frequency that's usually emitted by the sun. And what can it do? And the thing that it can do that's really dangerous about it, and why you're always recommended to wear sunscreen when you go to the beach or wherever you're going, is because it form in your nucleus. It forms these things called thymine dimers. And thymine dimers are these. It pretty much it forms double bonds between the thymine nucleic acids and making them sterically hindered or making them harder to move or harder to break. Uh, so what happens is when you're replicating your genome, you're not going to replicate as efficiently or adequately and you're going to end up potentially causing some replication errors due to that. You can potentially over at the end develop cancer. So uh, make sure you wear your sunscreen and always stay protected under any sort of high light frequency. It's not just UV radiation. You can also have X-rays, right? X-rays, probably gamma rays, X-rays. I think it's X-rays or gamma rays. Gamma rays I know is the highest, but I can't tell if it's gamma rays part of X-rays, right? Or X-rays its own category. But anyways, those are very, very, very high energy frequencies, and it will take a lot more than sunscreen to protect you from those. That's why when you go to the hospital, the radio techs usually make you wear these vests, and then once they take the X-ray, they'll be hiding in behind a room, making sure that they stay away from that because that can cause immediate potential high chance of developing mutations and probably leading to cancer or death. Number two is water retention. So kind of this one is also an obvious one because your skin helps make sure that the water or any fluid inside your body doesn't escape or get vaporized, right? It turns into vapor, evaporate. So it helps maintain that fluid. And actually, what happens is when you get a sunburn, what's going on is during a sunburn, what's going on is the sun has heated your skin so much to the point all the water leaves and your skin becomes dehydrated and starts to crust and gets damaged. And that's how you end up developing the horrible feeling of pain when you're sunburned that lasts for a couple days. That's why it's very recommended that when you go to the beach or whatever, you're drinking a lot of water and you're staying hydrated. Number three is vitamin D synthesis. So vitamin D is a very important vitamin that is pretty much helps in manufacturing of calcium ions, right? And making it and so where in calcium is very important for bone structure. So vitamin D, as you can tell, can help with bone strength, bone structure, and bone viability over time, longevity, right? So actually being exposed to the sun can help generate vitamin D synthesis. Can help generate calcium manufacturing. So vitamin C is a compound that gets converted to other compounds that then generate calcium. But that's pretty much for it for that one. We're not going to do too much in detail. Number four, sensation. You have on your skin, especially later on, you will get to see on your skin, on the dermis and the hypodermis. Well, actually, in all layers, but those you pretty much have sensory receptors that help make you feel the sense of touch, right? You know, when you touch something, you know how it feels, you know what it is, right? Based on its textures, based on and you actually have specialized cells that we didn't go over yet called Markel cells, and these cells are specifically designed to sense for pressure. They're considered a class of baroreceptors in our body. Okay. Number five, thermoregulation. This is probably a huge important. So thermoregulation is pretty much where we can we can use our skin to cool ourselves, right? So as I mentioned right up here, these hair cells actually have a very important function, right? So when you get very, very cold, what happens is that this muscle right here called the erector pili muscle will constrict, and it will make those hair cells kind of constrict and move in like a perpendicular fashion, like a closed fashion, kind of creating like a like a forest under your skin. And what that forest does is it pretty much traps heat. It traps heat, making the energy harder for it to escape, thus maintaining your temperature. Vice versa, if you're getting very cold, if you're getting very hot, what happens is you start to sweat. And what it is that energy is being traveled to the sweat. And as that energy is implementing into the sweat, that sweat will vaporize and goes into the atmosphere. So technically you're transferring all that energy into the atmosphere, by turning it into by turning that sweat into vapor. And that is so cool that you can do that. And also right here you could see on the upper picture that when you're very hot, right, like a summer day, what happens is your blood vessels will begin to enlarge, or better terms, dilate, right? They would begin to widen up, and that widening actually creates little gaps between the blood vessels, allowing for fluid to escape much easier, right? And therefore, as they escape, you begin to sweat more and secrete that liquid out of the skin, right? And that's what happens in some places like inflammation. If you get sick or something, that's exactly what's happening is your blood vessels will begin to dilate, creating little open holes, kind of little, I wouldn't say holes, but little open slits between those cells that compose your blood vessels, allowing for things to like uh white blood cells or protective cells to be able to enter and exit out of these blood vessels much easier, right? I mean, you have this mechanism not only just for water, fluids, or substances, material exit the skin. You have this also for protective measures as well, right? Or to regulate blood pressure, right? You regulate blood pressure by dilating your blood vessels or whatnot and constricting them. Now, for the second picture, this is what happens when you're very cold. Okay, when you're very cold, you don't want to do like picture one and waste that energy out of the system, right? You want to keep it, you want to constrict it so you can maintain your internal temperature at the temperature it's supposed to be, which is, I think, about, I'm not very sure, I think 37 degrees Celsius. I think it's 37 degrees Celsius. So you want to maintain that core temperature at that level so your blood vessels will constrict, making heat a lot harder for it to escape. And you can also see that the distance for the travel becomes a lot longer compared to this. Look how short the distance is for energy to travel out, or the energy to travel out compared to this, right? So it makes it a lot harder for energy to escape, therefore maintaining your energy inside your body, keeping you warm. And finally, I guess nonverbal communication. Well, if you can think of your face, right, when you're mad or sad, you give kind of faces, right? People can tell a lot about your emotion and how you're feeling just by looking at your face or your facial expression. So, those are many a good bit of the ways our skin helps us. There's a lot more things than this, but these are kind of probably the main uh function of the skin. Okay, slide number 4. So now we're gonna go into the skin, right? You can see that I've talked about these layers. So the epidermis. So what is the epidermis composed of? The epidermis is composed of these specialized cells called stratified squamous epithelium. Okay, and stratified just means a group, a uh, a group, or like, yeah, a group of people. You can think about it as a group or a compaction or a concentration. Okay, squamous is the type of cell we're dealing with, and squamous, if I can see if I could draw, but anyways, squamous is just this little oval. Like I would mix it between like an oval slash a diamond shape and mix them together, kind of cell, right? I don't think I might have this somewhere here. Yeah, maybe like this right here. So this is kind of the structure of a squamous cell. Uh, this is a little better. This is kind of the structure of a squamous cell, like that, like ovally, diamond, kite shaped little cell. And so an epithelium is just the type of cell, right? Epithelium. This pretty much type of cell composes probably about maybe like 85, 90. I'm not sure the percentage, but it composes about that much of your body, right? Your blood vessels are actually called endothelial cells, but they're also a type of epithelial cell, right? So You can also have different types. You can have, which are not mentioned here yet, but you can have cuboidal, and then you can have columnar. And so cuboidal are these like cube-shaped cells. Columnar, they look like columns or cylinders, cylindrical cells. And they don't have to be stratified. They don't have to be grouped as a bunch. They can just be linear or simple, or we call simple. So they'll just be composed of like one line. So this right here, this line right here, if I were to take all of that away, would just be simple, right? But this is definitely stratified because look how much they're grouped up. But if it was just one line of cells composing one form of one type, right, that would have been simple. Now we're going to go into the dermis, and also the epidermis, which we will talk about later, has about it has 4 to 5 layers depending on the thickness of the skin, right? You have regions in your skin, in your body, that are much thicker in skin than others. So you can have 4 to 5, okay, which we will discuss. And then the dermis. The dermis, I would say, is probably the main layer, because this is the layer where you have your blood vessels, your nervous tissue. You can potentially have a little bit of fat in there as well, even though we were not into the fat layer. This is where you have your something called your lymph nodes, or lymph vessels, which are these vessels that usually contain white blood cells, and pretty much your defense vessels, right? And then you have your blood vessels, which supply nutrients and take take wastes away, right? And then you have your nervous tissue, right? Because you need your nervous tissue to sense and conduct have sensory action and motor action. Okay. But your skin is mainly a sensory, so there's no really motor action when it comes to it. It's just a piece of tissue or organ that sends information, right? Okay. And the dermis. So again, I'm sorry, we're still talking about the dermis. So the dermis, as I mentioned, is composed of areolar and dense irregular. I'm sorry, I called it reticular. I just remember reticular, but it is irregular. Okay. Areolar and dense irregular connective tissue. And what dense irregular connective tissue is hopefully I'll have a slide down here that will show you what it is, but pretty much it's, yes, there we go. Like you can see this layer right here. Look how irregular this looks. Look how just cluster catastrophically uh, disorganized this looks, right? This just doesn't look smooth, doesn't look like anything like that. And that's what we mean by irregular. And you can see it's very dense. So that's what I said, that's what we mean with irregular, right? You can probably see a little hint of that here as well. And then this layer, and then here, this is and then it's also areolar. So areolar, I can go back up, is this little matrix right here. It's this little fluidy matrix that houses this. So it's both. It can be the fluidy, and it's also irregular connective tissue. So like maybe try to imagine a cube and think about it like three-dimensional cube, and think about it being so concentrated but also free at the same time in some sort of fashion. And then we have the hypodermis. So the hypodermis is pretty much this fat layer that's going to connect the skin to technically the muscle and stuff like that. And then the muscle connects to the bone, and pretty much, yeah, that's it, or so on. So it also, the hypodermis acts as a cushion, right? It cushions, like think of a pillow, and you're trying to put your head on the pillow, and that you sleep well with the pillow, right? Imagine if you didn't have a pillow in your mattress, right? On your mattress, you wouldn't sleep as comfortably as with a pillow, and that's what the hypodermis does for your skin, right? Or actually, fat in general, that's what it does, right? Other than storing energy and supplying and being broken to supply energy, it has a lot of other properties to it. It can insulate, it can insulate, it can trap heat, it can make things conduct action potentials potentially conduct faster, and all of that. But we're not going to focus on that. So fat really has huge functioning in your body. Okay, it's not bad at all. Unless you kind of go haywire on the fat, right? And here it says it's mainly adipose tissue. Again, it's adipose tissue is just fat. Okay. And I think we'll stop at this slide and continue on the next one. Uh, so thank you guys very much and see you on the next one. Let me stop recording.